In this presentation, we're going to see why Microsoft Dynamics NAV is fast. We'll go through the some index field technology, the .NET code in memory and optimized code for SQL Server. We'll go through the 3-tier architecture, batch jobs, aggregated data, and we'll finish with recommendations. So on the chart of account, for example, we see that we have net change, balance at date, and balances that are totals that are calculated directly. And so all the totals are calculated on the spot, and that can be filtered. So here with a department filter, all the totals are calculated instantaneously. So how does NAV does that? It's because of a technology called sum index field, and on the underlying table, on the keys, so NAV will maintain some totals directly, and we don't have to wait for the response. So to do that, NAV use index views. That's on SQL technology. So here GL entries, we have index views maintained. Then a simple thing like posted document and posted document. So NAV use mainly documents to enter information. And here is a list of the existing documents, that is to say documents currently in the system that are not posted. So if we post this one, this order 1075, once it is fully posted, it will not appear on the list. So the amount of data that NAV needs to work on still remain about the same. It reflects your activity. And once it's posted, it goes to a posted document. Now, .NET manage code and in memory. So the code of NAV is compiled by the .NET framework, which is a very, very quick technology. So that's a graph, so showing improvement made on NAV 2013 compared to previous versions. So using the in-memory and a bulk insert. So the in-memory here, I've just started my laptop and SQL is running on it. So the first time we do something, it takes some time. So here I put the sell to customer, and there is some code running after that. And the first time it's taking some time. But on the server is meant to stay on for a long period of time. So the second time or the time it becomes much quicker, because this code is now maintained in the server memory. Now let's look at the bulk insert technology. So it's optimized code for SQL Server. When we post, like here for example, physical inventory journal, all the posting occurs just at the last time in one transaction for SQL Server. So it's much quicker than doing it one by one. Now let's look at the 3-tier architecture. So NAV was redesigned in the previous version, NAV 2009, with SQL Server, a NAV servers, and let's say we have computers, could be tablets, devices, or other machines. So that's the database tier, the middle tier, and the client tier. Client could be, so the database tier manage the data, middle tier execute business logic, and client tier is a user interface with a choice of client, RTC, web client, SharePoint client, or web services, which are machines speaking to a NAV. So NAV, the client interrogates the NAV server, which interrogates SQL, and the response is going back. We can have multiple NAV servers that execute code in memory and can run batch jobs and scheduler. And SQL has bulk insert, optimize queries, keys on indexes, and maintenance plans. So that's the middle tier. So we see we have a number of sessions. So if we need to, we can create multiple middle tier. So that's the NAS service, that's the handling the job scheduler, batch jobs. And this is the web client. So let's look at batch jobs running on a scheduler. So running, but what we saw before on the NAS services. And in NAV, that executes the job queues where we can create batches and indicate the frequency, recurrence, which day, and the number of minutes between each jobs. And we see that some of the jobs, like posting invoices, can already be been posted out of the box with the job queue, job scheduler. Now we have some aggregated data technology that is already out of the box in NAV. In the analysis views, for example, we have we can have some compression. So NAV has some technology under the hood to make it very fast. So that doesn't mean that we shouldn't give any consideration for the speed. So it would depend on the number of users and database size. Under 20 users, or let's say 10 gigs, we shouldn't worry much about this. Above, we should keep in mind certain principles. So here some general recommendations in terms of setup, inventory setup, dimensions, chart of accounts, and attachments. So that's general recommendation that needs to be used on a case-by-case basis. So if we go to the inventory setup, we could have this inventory online to the GL, or posted by batch, adjusted by batch. So depending on the volumes of transaction, we could use one or another. And we can also, if we choose not to have that online, we could automate that to post the transactions every night, for example. So by creating a job queue and running the proper batches, we can run that every night. Some consideration about dimensions. So here are a number of dimensions can be used. If we have a large database or many users, maybe we should not overuse dimensions. Here, for example, that could be a simple do we use dimensions, that is information is tracked on every entries, or is it a simple field like here in the customer card? By designing also the chart of accounts, we could have some level of details out of the box. What is the level of details per GL account per dimension that we want to have? For example, in your inventory, it's possible to have one account or several accounts. So accounts could be by location or by type of items. So that's a balance. Whereas if you rerun the inventory valuation report, we could put a location filter. Now for attachment, that could be embedded into the database, but it takes some space, so makes the system a bit slower. Or everywhere we've got attachments that are links, and that takes almost no space to the database, as it is stored in a network location. Now let's talk about flow fields. Very powerful technology. So if we go to a card, we have a number of flow fields. This information coming from other tables, and usually by default NAV doesn't show that in a list. However, sometimes it could be very handy to have that on a list. So here, for example, we have a custom list of stock keeping units showing lots of flow fields. So it's very handy, but it consumes some resources. So it's a balance against between usability and speed, and we could use profiles not to show the information to all users. Here on the role center, all that activities are pretty quick because they just counts, but we could add some statistic information which takes longer to calculate, and each time we open the role center it is calculated. So do we have live data, or do we process the data overnight so that it gets quicker to be calculated? Again, that's a balance. So some jobs, like in the planning worksheet or requisition worksheet, to recalculate what we need to order or to produce, that takes some time. So another approach could be to push the data by email with PDF attachment. We have everything we need in NAV to do that. With a large database or with many users, we could have a different approach to use reporting services, cubes, Power Pivot, instead of using NAV, which is a relational transactional database. So in NAV we have the some index field technologies and flow fields, but that takes some space and time. So instead we could use analysis services to make all the calculations overnight on batch, or Power Pivot that use the same technology. In terms of SQL setup, so that would need to be detailed, but very quickly we'll put normally the log and the database files in different drives. We can set up some memory to take a lot of memory for SQL Server, but let some for the operating system, and we put some maintenance plan. Changes in technology in terms of SQL Server going to be in memory databases, and with Windows Azure coming soon for Dynamics NAV. So NAV 2013 is already very fast and scalable. And I think this technology will even bring us further.